planets get their ingredients? To actually understand the origin of our solar system ingredients, we need to first consider the environment from which planet ingredients was formed. And this is what you're actually looking at, an image of a molecular cloud, which is a mixture of gas and dust, in which a star is going to form, and then later on potential planets. But let's summary in more detail the stages of star and planet formation, starting with the molecular cloud. The molecular cloud is going to condense on itself and collapse to create a newborn star. This star is going to have a lot of energy, creating ejection, a lot of burst, and a lot of turbulences, until the materials settle in what we call a protoplanetary disk, in which planets are going to form in it and create a planetary system. But let's start from the beginning, the molecular cloud, where everything exists. So we have 99% of gas in the cloud and only 1% of solid dust grain. And this 1% is the only place where chemistry happens in space. A dust grain is made of silicate and carbon, the same one you can have on the floor, and then coated with ices, mainly water, which is the main component in space, and then smaller molecules like CO, carbon monoxide, carbon dioxide, or even methane. And we have multiple of those ices in the cloud. But if we look at those stages, we notice that when the star is present, the star is going to induce energetic processes like UV radiation, heat, that will change the chemical composition of those ices that will then get incorporated in the planets. And so for my research, I'm focusing on the protoplanetary disk stage and how the heat from the star can change the chemical composition in the forming planets. So here are our disk, where we have the star in the middle, and the star sets a temperature gradient across the disk, where we expect molecules to be freeze out or in a solid form further away from the star. And then if those ice get closer to the star, then they will desorb or sublimate and be in a gas phase. And this sublimation temperature are specific for each molecules and will be defined by what we call snow lines. In the literature, those dust grains are believed to be layered in a uniform layer with the dust, then water, then potentially carbon monoxides, which means particularly defined snow lines, where we'll have first desorption of carbon monoxide and then desorption of water. But what does it mean when we compare this to our solar system? Let's take the example of Venus. Venus is really close to the star and will be present in the regions where only water is present in a solid form. What about Earth? Because Earth has life, right? So how does those ingredients get incorporated in Earth? Well, Earth is actually in the same regions. So how come Earth has life? Well, an important detail that we have to know when we create those planets, everything that is in the gas phase ends up in the atmosphere of a planet, but everything that is in solid phase, so ices, we end up in the core of planets, which means emergence of life later on. Sorry, gas phase is atmosphere. And so I wanted to challenge what literature said about having layered ice. What happens if we actually have fully mixed ices? What would happen to those snow lines? Well, to do so, I use a setup that mimics space conditions where we have really low pressure and really low temperature, where I'm creating a mixture that I'm depositing in the chamber, and that creates an ice. And here's an actual picture of an ice. With this study, I found that if you start with a fully mixed ice, the molecule will not desorb anymore at their expected temperature, and instead they will get closer to the star in the solid form, and so end up in the core of forming planets, which will be later on be important for the emergence of life. So how do planets get their ingredients? Planets inherit their ingredient through cosmic ices, and the chemistry of those ices will set what the planets are made of and the possibility of ingredients for life. And that matters with mixed ices, since they will be more available through the disk. Thank you so much.